Hi to everyone, this is your Shankarappa sir. In today's video, we will discuss about microwave devices and their measurements of the different parameters. By using the microwave bench setup, we can measure the different parameters like scattering matrix of the magic can be determined, VSWR can be measured, VSWR measurements can be done, attenuation measurements can be done, frequency and wavelength can be measured, and also direction coupler characteristics can also be determined, and some more parameters like gun diode characteristics, the reflex klystron characteristics are also to be measured by using the microwave bench setup. Now we can see what are all the components it may have and how they are to be operated at different levels of the frequencies. Okay, it is a used microwave bench setup to measure the different components which are to be done in the laboratory. Now we can see the different components of this microwave bench setup. First, this is the microwave source. So here the source is the klystron power supply. Source is the klystron power supply. And next, this will be the klystron mount. So it is the klystron mount. So this one is the klystron mount. And next one is it is isolator. And this one is the variable attenuator. And this is the frequency meter. This one is the frequency meter. And this will be the slotted section, slotted section. And this will be connected with the detector mount. So it is the detector mount. That probe will be connected to the detecting meter, either to the CRO or to the VSWR meter. So it is the used bench setup to measure the different components of the microwave, or the different experiments are to be done by using this microwave bench setup. Now, it is the microwave source. It is a klystron power supply and a klystron mount. These two are called as the microwave source. When the experiment is ready to conduct, the first step while doing the experiment is switch on the fan. So it is the fan. This can be switched on. Later, the microwave source, that is klystron power supply source, is to be switched on. Klystron power supply is to be switched on. So if you observe, this klystron power supply has a meter select. So it has the meter select. It has the three terminals, V, C, R, E, P. V will be the representation of the voltage and the current, and this one is the repeller voltage. And this has beam voltage and repeller voltage. Initially, this to be kept at the voltage level, and HT is to be on. By keeping this at voltage level, you adjust this beam voltage to get the 230 volts in the meter. So get to adjust this to the 230 volts. So it is 230 volts. Now after 230, you turn this terminal towards the current. So initially you have to note down that 230 volts. The beam current is also to be noted. It is a beam voltage. Initially the beam voltage is 230 volts. Later the beam current is 15 milliamps. Then this to be moved to the repeller. Now by adjusting this repeller, by adjusting this repeller, we have to observe the perfect square wave in the CR. Perfect square wave in the CR. If there is a perfect square wave in the CRO, then we can say that it is to be under the perfect condition. Bench is to be operating under the perfect condition. If there is no proper signal, then we will not receive any perfect square wave in the CRO. Until to get the CRO as a perfect square wave, the bench is not to be under proper condition. Once we get the perfect square wave in the CRO, then we can assume that we can say that the bench is to be under the proper condition. It is under the proper condition. Bench is to be operated under the proper condition. Now, for any experiment, we have to get these primary instructions. First one is the beam voltage. It has to be kept at 230 volts. It has to be kept at 230 volts. Later, the beam current is to be noted. Later, it is to be moved to the repeller voltage. The repeller voltage is to be noted. By noting that, get the perfect square wave in the CR. Get the perfect square wave in the CR. So it is the bench setting. Now, by using this, we can do any experiment which are to be connected by this microwave bench setting. It is the H-plane T junction. It is a 3-port junction device. So it is the 3-port junction device. It has 3 ports. It is port 1, port 2, port 3. So in the case of H-plane T junction, the rectangular waveguide section is to be cut along the narrow dimension. So it is to be cut along the narrow dimension. So it is to be the narrow dimension. One more waveguide section is to be attached to form the H-plane T junction. Its matrix can be represented as 3 by 3, varying from S11 to S33. It is already explained in theory of H-plane T junction. Okay. Similarly, it is the E-plane T junction. This one is the E-plane T junction. So it is the E-plane T junction. It is also a 3-port junction device. Can be represented with port 1, port 2, port 3. So in this, the wider dimension of the waveguide section is attached with the one more waveguide side arm. This will form the E-plane T. So in the case of E-plane T, wider waveguide section is to be cut and attached another waveguide to form the E-plane. Where in the case of H-plane T, a narrow dimension of the waveguide section is to be cut, another waveguide is to be attached to form the H-plane T junction. So by using this E-plane and H-plane, one more T junction is to be formed, that is the EH-plane T junction. Otherwise, it may also called a magic T junction. So it is the magic T junction. It is a 4-port junction device which contains the 4 ports. Can be represented with port 1, port 2, it is port 3, and this is port 4. I can show you that one. It is port 1, this is port 2, this one is the port 3. So this H arm is the port 3 and this is the port 4. E arm is the port 4. It is a 4-port junction device. This can be formed with the combination of E-plane and H-plane. This may also called as a hybrid T junction. It is to be called as the magic T because whenever the power is to be applied at one port, exact opposite port will have the zero output. That is the magic of this T junction. It is the used bench setup to measure the magic T parameters like isolation, insertion loss, and coupling factor. By using this magic T, we can determine the insertion loss can be determined, isolation can be determined, and coupling factor can be determined. So initially, the detector is to be connected to the VSWR meter. The corresponding reading is to be noted from the detector mount, from the VSWR meter. That will be the P3. So after noting down that P3, so here we are getting the value of 21.50 decibels as P3 in the case of Magic T. So after noting down this, you switch off this HT. HT is to be switched off. Now this detector is to be removed, a Magic T is to be connected. Now the HT is to be on. The HT is to be on. So this Magic T is to be connected. So in this port 1 is to be connected to the detector mount. So 1 is to be connected to the detector mount. 2 is terminated, and this 3 is also terminated. Magic T is to be connected to this slotted section. Port 1 is to be connected to the detector mount. 2 is to be terminated. 4 is also to be terminated to find the value of P1. That P1 is to be calculated by using this VSWR meter. So here P1 value is getting as 27.40. The P1 is 27.40 decibels. Once again, so in order to find the port 2, port 4 outputs, the terminations are to be interchanged and detector is to be connected to that particular port. So in order to calculate P2 and P4, this HT is to be switched off. In order to find the port 2 output P2, now HT is on. After switched on, this is the port 2, this one is the port 2, this is port 1, it is port 4, port 2, port 1, port 4. This port 2 is to be connected to the VSWR meter. Now you can see this port 2 power has the value of 27, because port 1 also having the same value, almost same value, because port 1 and port 2 are the isolated ports, collinear ports. Due to that reason, whatever the power is to be getting at port 1 will be the same power at port 2 also, or we can say that in the case of Magic T, when the power is to be given at port 1, the exact opposite port will be 0. So here we can observe port 1 and port 2 will have the same power due to its isolated ports. Port 1 and port 2 are the isolated ports. So in order to find the power of P4, as usual, this HT is to be switched off and the termination blocks are to be interchanged. So this is the port 4, this one is a port 4, it is to be connected to the detector mount, and remaining port 1 and port 2 are to be terminated with termination blocks. Now need to find the value of P4. So for that, now HT is on. After HT on, this port 4 will be the detector mount. This port 4 having the detector mount. This detector mount is to be connected to the VSWR meter. So here range is to be required. So you can move this range. Here the range is to be required. The previous range is not to be sufficient. So now we can change this range. It is also to be required. Now this has the value of 40.97. It's around 50. Let it be 50. 50.10 decibels. P4 is identified as 50.10 decibels. Now by using this P1, P2, P3 and P4, we can determine the parameters like coupling factor, isolation and insertion loss. After completion of the experiment, we have to switch off the HT and the power supply. HT is to be switched off and the power button is to be switched off. So it is about magic T experiment. So by noting down the values of P1, P2, P3 and P4, we can determine the different parameters like insertion loss, isolation and coupling factor by using the formulas of insertion loss L equal to P1 minus P3, isolation capital I equal to P3 minus P4 and the coupling factor C equal to P1 minus P4, all in terms of the decibels. So it's about magic T. I think you can understand the magic T experiment and their parameter calculations in the microwave laboratory. Thank you all for referring my video and seeing my video. I am requesting you all subscribe, share and like my videos. Thank you all.